Good morning, my students. We are going to study some revisions about the electricity. Write down the scientific term for each statement of the following. Electromagnetic interaction between two coils which are kept close to each other or one inside the other. When an electric current with time-varying intensity passing in the coil, this coil is called the primary coil, produces in the secondary coil which is connected with the galvanometer, and induce the current in a direction that opposes the variation of the current intensity in the primary coil. Electromagnetic induction between the two coils, when the coils are kept close to each other and current intensity changes in the primary coil, is called mutual induction between two coils. This is the answer, mutual induction between two coils. Induced number 2, induced electromotive force generated in one of the two coils when the induced current in the coil changes by rate 1 ampere every second. Induced electromotive force generated in one of the two coils when the electric current intensity in the other coil it changes in rate 1 ampere per second is called coefficient of mutual induction between coils. Coefficient of mutual induction between two coils. The third point, the coefficient M has symbol M. Coefficient of mutual induction between two coils, that if the electric current intensity at one of them is changed in the rate of 1 ampere every second, it generates between the ends of the coil induced EMF is 1 volt. This is called Henry. This is called Henry. Henry is the unit for measuring of coefficient of mutual induction between two coils. Number 4, electromagnetic effect that takes place in the coil that resists the change of the current passing through it. Again, electromagnetic effect takes place in a coil. And the first question, electromagnetic induction takes place between two coils. This is called the mutual induction between two coils. The electromagnetic effect that takes place in a coil is called self-induction. Self-induction. Number 5. The magnitude of the induced EMF generated in a coil when the electric current intensity passes through it. It changes in rate 1 ampere per second. This is called coefficient of self-induction. This is called coefficient of self-induction. Number 6. Induced current that produced in a metallic piece, due to the change in the number of magnetic flux lines that cuts it. This is called eddy current. This is called eddy current. Eddy current characterized by high thermal energy. Choose the correct answer of the given answer. Current passes in the primary coil. Current passes in the primary coil. The coil is belonged into the secondary coil, whose terminal is connected with the galvanometer. The deflection of the magnetic needle will be in the direction opposed to the direction of the current in the primary coil. Point to the zero reading. Deflects in the same direction of the current in the primary coil. Deflects right and left side of zero scale. When the current passes in the primary coil, is belonged into the secondary coil, backward induced EMF and backward induced current is formed. This means that the current is opposite to the current in the primary coil. Current in the primary coil, the source of it is a battery, while in the secondary coil, the source of current is induced current due to the change in magnetic flux. Due to the change in magnetic flux. When closing a primary circuit while inside the secondary, leads to generate by mutual induction. Induced forward current, continuous current DC current, alternating current EC current, induced backward current. Backward induced EMF and backward induced current are generated in the three states. When the circuit is closed, when the current intensity increases, when the primary coil belonged inside the secondary coil, in this case is belonged inside the secondary coil, this means that the answer is D, induced backward current. At the moment of opening the circuit, of the primary coil inside the secondary coil, opening the circuit. This is the secret key to solve the question. At the moment of opening the circuit of the primary coil inside the secondary coil, although it is inside the secondary coil, but opening the coil, having the number of turns, space generated in the secondary coil. Big number A, big back EMF, big forward EMF, small back EMF, small forward EMF. The circuit is opened. When the circuit is opened, when the current intensity decreases, when the primary coil is pulled out from the secondary coil, forward induced EMF is produced. Forward induced EMF is produced. This means that big forward induced EMF generated. Question number 4. In the opposite figure, in this figure, this battery, this is called the primary coil, and this is called the secondary coil. The battery is the source of electric current. The current move and go down through it. And the other circuit contains the battery. The current move up. This means that the lamp glow due to the current. In the opposite figure, when decreasing resistance, the resistance decreases, the current intensity increases. When the current intensity increases, backward induced EMF is generated. This current move down. Opposite to it, move up. This means that the direction of the current or induced current in the same direction of the battery means that the current increases. The current increases. This is the answer of this question. Number 5. Like it, battery produces electric current move down. This is the secondary coil has no battery. In the opposite figure, during increasing the variable resistance, this resistance increases, R increases. This means that I decreases. I decreases. When the current intensity decreases, backward or forward induced EMF, we study hard when the resistance increases, the current intensity decreases. The current intensity decreases. The current intensity decreases according to mutual induction between two coils. Backward induced EMF is produced when the current intensity increases, when the primary coil is, when the primary coil is closed, when the primary coil inserted inside the secondary coil. In this case, resistance increase and the current decrease. This means that forward induced current are produced. Forward in the same direction. In the same direction. Current flow from point A to point B. This means that the potential of A in the same direction or in the opposite direction. In the opposite direction, the current move from P to A, from high potential to low potential. This means that A is less than B. When the direction of the current is reversed, it becomes greater than. It becomes greater than before. Two similar circular loops carrying equal current in the same direction. On moving the coil farther apart, the electric current will be remains unchanged, increases in both of them, increasing in one, decreasing in the other, decreasing in both. Two similar coils loops carrying equal current in the same direction. On moving coil farther apart, the current will be increases in both of them. The slow rate of growth of the current in the solenoid is due to production of forward effective current, production of reverse induced EMF, which resists the growth of the original potential difference, production of magnetic flux, production of an electric field. The answer is production of reverse, which resists the growth of the current. Coefficient of self-induction in a coil is measured by unit is called Henry. Henry equal Henry H equal ohm second equal ohm second. When a fluorescent lamp lights, space energy stored in the coil, magnetic energy stored in the coil. Magnetic energy stored in the coil is discharged in the evacuated tube filled with an inert gas, After a while of the flow of the continuous electric current in an induction coil, its intensity becomes constant due to generation of current, generation of eddy currents, vanishing of self-induction, presence of back current. The answer is vanishing of self-induction. Goodbye and good luck, my students.